Hi everyone, I will give a brief introduction about basics of circuits and electronics in this video. Unfortunately, it's not possible to cover the full extent of an introduction to electronics class, but I hope that you can get familiarized with some circuits elements after watching this video. If you already have some experience with electronics or hardware, so you can skip ahead and watch lectures for Monday. There is a very short summary of what I will talk about today on Karma's wiki page. So if you go to these links, you might find more written examples of what we're covering today. Just to overview the basic components of circuits, there are passive elements and active elements in an electronic circuit. Passive elements are mostly resistors, capacitors, inductors, sometimes switches. Um, These elements do not control the current in a circuit or provide power to the circuitry. Uh, on the other hand, active elements instead supply energy to a circuit. Voltage, current sources, transistors, or diodes are active elements. What you will mostly use in these simple circuits are usually capacitors, resistors, inductors, and especially transistors and diodes too. Some sensors function as simple as a resistor or diode, while some are more complex, like an integrated circuit. An integrated circuit can be your accelerometer or or more complex or like a microphone amplifier. So these will come in small chips that you might find in your kits or need to purchase later or order later to finish your projects. One of the most fundamental law in circuits is the Ohm's law. That means that the current flowing through the circuit times the component's impedance, in this case is resistance, equal to the voltage consumed. For example, there's a very simple example here. 10-volt voltage source is providing current to this circuit, and circuit only consists of 100 ohms resistance. So this resistor will let only 10 milliamps current to flow, because if you divide 10 volts by 10 ohms, it will end up having 0.1 amps, which means that it's 100 milliamps. So this is a very basic conversion, but it's very useful, and you'll be actually using this very frequently. Without going too much into the details about different connections like series or parallel, I will explain what a voltage divider is. In a series connection like this, when the resistors are connected in series to each other, they're not parallel as opposed to the other common configuration. The current in the circuit is maintained and the voltage is divided proportionally to the resistors. And this is used very frequently with sensors and pull-down resistors to stabilize the circuits. We have a very similar case in this one. So it's a very simple sensor, which is a photoresistive sensor, sometimes called light-dependent resistors, LDRs. There are simple resistors. Their resistance change with the light illuminated onto the sensor. So the resistance actually decreases with the instant light increases, resulting a higher current to flow through the circuit. What we have it here is a simple voltage divider like we saw earlier. You have a 5 volts power supply that is either 5 or 3.3 coming from your controller, creating a current flowing through the sensor and the pull down resistor. Where we get the voltage output will give us a voltage that changes with the light illuminated on the LDR sensor. Now I'm going to demonstrate the circuit with you and then see how the circuit is constructed, and how we can read the data. For this simple circuit, we need a controller, a prototyping board, three jumper cables, an LDR sensor, these are also called photoresistors, and a 10 kilo ohm resistor. All of these are included in the kit. I will start by connecting the positive terminal to 5 volt of the controller. I will do the same for the ground and connect the ground pin of the controller to the negative terminal of the board. Now all of these positive pins and the negative pins are connected to each other on a vertical line, positives and negatives being separate. If you remember the circuit, the LDR connects to the positive terminal, and on the other end it connects to the resistor. I will pin it to any free connection on the board. At this moment it doesn't matter. In that series of pins side by side, all 5 pins are connected to each other here. The pull down resistor goes to the same pin and connects to the ground. Now the circuit is complete. The last thing we need to do is that we'll connect the output pin where the sensor and the pull down resistor meet to the A0 analog pin of the controller. And very shortly I will show the code and how the data seems in the serial terminal. When I change my finger's location so the light on the sensor, the values will be changing. As I get closer, the values will be dropping. This is a very simple code where in the serial function, it initializes the baud rate of the serial port. Important note here is that the serial port rate needs to match in the serial port and in your code as well. So make sure that two baud rates match each other. In the loop function, it reads the analog input data and sends it to the serial port to print. By clicking to the top button where it says Serial Monitor, you can see the Serial Monitor window. Now you can see the data decreasing and increasing on the Serial Monitor as I change the light on the sensor. The same simple circuitry can be constructed for sensors like FSRs, force sensitive resistors, or bend sensors for many resistor-based sensors. Just to remind you again, please follow one or more of the tutorials that comes with the kit to help you set up and familiarize yourself with the Arduino coding. And feel free to select any sensors or projects that is suitable to yours. Good luck and let us know if you need any help.